Hey guys, welcome to day one of the quarantine. Um, Hopefully, you guys are staying safe out there and self isolating and social distancing yourselves. But I wanted to go over some questions from page 186 and 187. And so let's kind of jump right into it. I want to say thank you to Niam and Nana and Edward and Belle and Marianne, and if I'm forgetting anybody else who gave me some feedback or numbers to go over, I apologize, but thank you for your feedback. So let's kind of get into it. So let's get rid of my face here. Some things you really need to take note of is if the degree of the numerator is less than or equal to the degree of the denominator, there is a horizontal asymptote. Remember, the degree is the highest degree of the x value. So if we were to look at this example, the degree up top is 1 and the degree on bottom is 1. Why? Because it's 3x to the first power, x to the first power. That means there is a horizontal asymptote. Example 2, the power of x is 0. And so on the bottom, the denominator, the power of x is 1. So the degree on top is 0, degree on bottom is 1. That means there is a horizontal asymptote. And then there's the last thing you really need to know is there's a slant asymptote if the degree on top is exactly 1 more than degree on bottom. So in the notes, you saw that the degree on top here was 2, the degree on bottom was 1. That means there is a slant asymptote. In other words, an asymptote that's neither horizontal nor vertical. So those are some of the things that you need to really keep in mind. Another thing that I wanted to kind of go over is why is it important to see what's happening as x goes to infinity? Well, this is what we call a limit. As x approaches infinity, what's the graph doing? And specifically, as x approaches infinity, as we go further and further right on this graph, what's happening to our y value? And it's when we start to go further and further to infinity with our x values, that's when we really get to see what's happening with our y values. And so in this graph, which is y equals 1 over x, we can see that the further and further right we go, the closer and closer our y value approaches 0. That means there's a horizontal asymptote at 0. So basically, when we see what's happening as x gets bigger and bigger, we're finding our horizontal asymptotes. So that's why we see, that's why we take a look at as x approaches infinity. We're really interested in when x approaches infinity, our horizontal asymptotes are more obvious. So that's why we did that, and I think that's one of the questions that was answered. We could also see what's happening by going to negative infinity, but not necessary. So let's jump into this. The first question that we're going to go over is number 15. So let's take a look here. Okay, right away I'm going to notice that the power up here is 2 and the power here is 1. That means there is no horizontal asymptote, but there is a slant asymptote. Now, the instructions didn't ask us to get a slant asymptote, but if you wanted to find the slant asymptote, you have to use synthetic division. So the only asymptote here is where x equals negative 6. This is a vertical asymptote. And we can see this by, let's see if I prepared it over here in Desmos. I didn't. Great. But you can look that up in Desmos and see that there is a vertical asymptote at x equals negative 6. Why? Because our function becomes undefined when x equals negative 6. And again, there's no horizontal asymptote. Number 16, the degree on top and bottom. Well, if I'm going to look at the degree on top and bottom, I'm going to go ahead and FOIL this guy out. And so doing some quick FOIL, that's going to be 2x squared. 2x times negative 5 is negative 10x, plus x is going to be negative 9x. And then 1 times negative 5 is negative 5. Okay, so again, now the power up top is 2 and the power above is 1. So I know there will be a horizontal asymptote. So having said that, let me back up a little bit. I know that there's going to be a vertical asymptote when x equals 5, because it'll make this guy 0, and we can't have 0 in the denominator, but also negative 1/2. That's my son in the background, if you can hear him. But negative 1/2 would also make this are undefined. So those are our two vertical asymptotes. And so the technique that I showed you guys for finding a horizontal asymptote is basically multiply top and bottom by 1 over x. And this is a legal move because when I multiply something where it's the same number on top and the bottom, this is just a fancy way of multiplying by 1. So that's why that's a legal move. So I'm left with x over x minus 1 over x over 2x squared over x minus 9x over x minus 5 over x. Okay, now I'm asking myself, as x approaches infinity, what is happening here? Well, as we saw from the very beginning, this is going to go to 0. This is going to go to 0. And we're left with x over x is 1. 2x squared over x is just x minus 9. And again, I'm still asking myself, what's happening as x goes to 0 or as x goes to infinity? As x goes to infinity, the bottom, the denominator, is going to get bigger and bigger and bigger and bigger and bigger. And so this actually approaches 0. So as x approaches infinity, y approaches 0. So here are my vertical asymptotes. Here's my horizontal asymptote. Let's look at number 18. And actually, we can, going back to the previous answer, we can see that. I think I did. Look at that one. Yeah, we can see that there are 2 vertical asymptotes and a horizontal asymptote at 0. X squared over x squared plus 1. They have the same power. There is a horizontal asymptote. I'm going to use, there's no value of x that would give us 0 on the denominator. So there's no vertical asymptote here. But if I use my same technique, I can say that's equal to x squared over x all over x squared over x plus 1. Oops, plus 1 over x. Again, and then we ask ourselves, as x gets bigger and bigger, as x approaches infinity, that goes away. And I'm left with x over x, which is just 1. So as x approaches infinity, my y value is approaching 1. So I know that there is an asymptote at y equals 1. And by this graph, we can kind of see, yeah, there is a horizontal asymptote at 1, and there's no vertical asymptote here. Number 24. Number 24 said you have to describe the transformations taking place. I'll be honest, I'm not so much concerned with the transformations as much as I'm concerned with, do you know what the asymptotes are? So the original here was given, f of x equals 1 over x. We saw that from the beginning of this video. And if I'm looking at this guy, which is y equals 1 over x plus 3, I know that this is actually just f of x plus 3. And what that plus 3 is a vertical shift of up 3 units. And so I know the original has a horizontal and vertical asymptote at x equals 0 and y equals 0. It's still going to have a vertical asymptote at x equals 0. But now I have a horizontal asymptote at y equals 3. In other words, if I shift the graph up 3, my horizontal asymptote is shifting up. My vertical asymptote doesn't change when I shift up 3 units. Okay, so that's what they're looking for there. 29, man, this is a mean problem. I'll be honest, I really don't care too much about the transformations, but I do care that you know how to find the asymptotes. And so, again, we're going to use our technique where we multiply top and bottom by 1 over x. So that's negative 4x over x plus 2 over x all over x over x plus 5 over x. And as x approaches infinity, we know this is going to go to 0. This is going to go to 0. And we're left with negative 4 over 1, which is just negative 4. And so we can tell that there is a horizontal asymptote at negative 4. Our vertical asymptote is going to be when the denominator is 0 and my denominator is 0 when x equals negative 5. So x equals negative 5, that's my vertical asymptote, and y equal to negative 4. That's my horizontal asymptote. Again, I'm not too worried about the transformations there. That was an ugly problem. And then lastly, I think Bell asked about how do we find the equations below? So remember, the parent function is f of x equals 1 over x. And the asymptotes of this function, they intersect at the origin. So I'm noticing that this guy, that's my vertical asymptote, this is my horizontal asymptote, and they're meeting negative 3 to the left, 3 units to the left, and 1 unit up. In other words, this graph is shifted 3 units to the left, and also it's shifted up 1 unit. And so this is f of x, let's see, plus 3 of 1 unit, plus 1, which would give us the function y equals 1 over x plus 3 plus 1. Okay. This guy, if I look at the asymptotes, they intersect where it's shifted over 1, 2 units and down 1, 2, 3 units. So shifted right 2 and down 3. So this is like f of x minus 2 minus 3, which is going to give us the graph of y equals 1 over x minus 2 minus 3. Now, this guy, notice that the direction of these of this graph has almost been flipped, and actually this is odd. So you can think of this as a flip across the x-axis or a flip across the y-axis, either one. And so, but not only is it a reflection, I know that it's also been shifted up 1 unit because it has a horizontal asymptote of 1. So this is like f of negative x plus 1, which is going to give us the function y equals 1 over negative x plus 1, which is just the same as y equals negative 1 over x plus 1. So anyways, I hope that's helpful. Sorry that this was a super long video, but there's lots of questions to get to. Again, pay attention to the powers. Those are important. And the degrees, I should say. If the degree is 1 more than on top than it is the bottom, then you have a slant asymptote. If the degree on top is equal to or less than or equal to the bottom, then you have a horizontal asymptote. So anyways, keep the questions coming. Appreciate it. Thanks.